Hey all, my name is Mel, and I want to start with you with a little story. I was very fortunate to be participating a couple of years back with this very interesting project that happened. The internal procurement for this client used this very simple form to decipher, to try and understand the types of data that they want to purchase. So they had this drop-down menu for the category and the item itself. And if they needed, they could put down some free text as a description. But after a while, this very interesting thing happened. And the fact was that some of the users were actually using the drop-down menu and they were showing the different categories and names from the drop-down menu, but some did not. They were just using the free text. And the client asked us to try and classify these free text records based on the catalog so that they can do some business intelligence analysis and try to understand what they're spending their money on. So usually before you start modeling your data, you're doing some exploration, removing some outliers, cleaning your data, and splitting it into a train and validation sets. And it's very important because you don't want to test yourself on something that you've already learned. And keep in mind that in our case, the testing set did not have any labels, just the free text, whereas the training and the validation sets did. So we did some modeling, and what do you know? Those were great results. We were partying because we said, okay, we're on track. It seems like a very simple project. The same population, same catalog, no problem. But when the time came to show the results to our experts for some manual evaluation, well, not partying that much then, because the feedback we got was, listen, guys, some of the data you got correctly, but some did not. It just was way off. Go back to the drawing board and try to understand what's going on, what happened. And after a while, after speaking to various users and domain experts, we actually realized that the reason that those users weren't using the drop-down menu is because they couldn't. Those records were not in the catalog at all. Due to some technical reasons, the product did not ingest the new items for the catalog on time, so people were actually forced to use the free text just to get going with their work. And that actually created this divergence in processes of procurement within the same company for the same users. And in a gist, that's what data shifts talk about. This different causes that's causing the data to look very different and very hard to model. And that's what I'm going to talk about today. So my name is Malvina Matlis. Most people call me Mel. I'm a data scientist, and I've been very fortunate for the past 15 years to be working with people and trying to model data for various domains and trying to assist people get the best of their data and their business. And let's get going. So the reason that machine learning works, especially for supervised learning, is because there's this very simple assumption that says that the independent variables, which are the input to the model, and the dependent variable, which is the target, have some form of relationship. And while this relationship works, all is peachy. But when something breaks, that's when the different types of shifts occur. And most people probably heard of one form or another of a covariate shift or a model drift. And usually people would have just bin them together as this huge phenomena, but they are not. They have different root causes and they should be handled in separate ways. So let's deep dive into this. Covariate shift we'll usually discuss for the fact that the independent variables, which are the input to the model, are different. They have different combined distributions in the training and the test set, which is very simple to spot because you will train your model in the train set and you will see that the performance in the model varies between the different types. But the trickier part is to try and spot what happens in the second use case. And that's when the test distribution is very different from the real world situation, because then you won't be able to spot during research that you have a problem. The main issue for covariate shift is selection bias. We are biased people. We have our prejudice, And actually, our models just represent that, they display the same bias. And have a look at this research where a person was trying to estimate the age of people just by looking at facial features. And his model worked very, very well in Europe, but it failed in China because the entire project was biased. He did not think that he needed to actually learn facial expressions from Eastern looking people compared to Europeans. So that's selection bias. The second one that's very common is undersampling. So try to guess what those are. Embryos, planets, fairy lights. So those are actually retinal scans from mobile devices. And this study focuses on trying to estimate the levels of type 2 diabetes in patients just by using mobile scans. And if this study is being done in the US, then you have this huge problem because the US mobile market is highly, highly skewed towards the different Apple devices, which means that, let's say, the Xiaomi devices, if they are underrepresented within this study, it means that in the real world, when you apply this model in any other country, basically, other than the US, the results could worsen and you could misdiagnose diabetes just because you didn't train on the proper devices. So that's undersampling, and you need to be aware of that. And now let's say that you want to create a model that is going to predict the flavor of an ice cream, and the model is perfect. It will always get the right flavor of an ice cream. You have your ingredients, and it's chocolate ice cream. But what happens after a while is an ice cream still an ice cream, or is it more like a puddle of goop, basically? And that's the problem with models. They are stationary. And we live in this non-stationary world where time has effect and change on different aspects of life. And that's basically model drift. It means that nothing has changed in the independent variables, right? Milk and sugar are the same, they're not changing, and different flavors are the same flavors, but the relationship over time changes. Let's look at an example. Right now, we are all living in this huge, huge concept shift. COVID has changed everything that we know about our shopping habits, our mobility, our ability to analyze psychology, the way we talk, the way we move, the way we watch TV. Everything has changed. And it's super important to understand that you can't have models that were trained prior to COVID and try to apply them right now on in a world where everything has changed. Let's see. This plot represents the number of flights from 2019 to the end of 2020. And you can see that this huge dip, you guessed it, that's the outbreak of COVID-19. So if you think about it, in reality, not much has changed in the flight industries. The fleets are the same, the model of planes, the way you sit people inside the plane did not change drastically. Even the world population has not changed drastically. But you can't expect to have a model that was trained on that behavior, on that pattern, and try to predict it on this type of patterns. You need to keep retraining and reteaching your models to changes that happen all around us. Why am I telling you this? Is because you need to be aware that basically in every single data science model, no matter what the domain is, some form of non-stationarity or bias might happen, and then you can experience the different data shifts. Why is it important? The idea is that something around 1/4 of the time within a data science project model, when you're doing your modeling, you will spend on preparing the data, cleaning it out, splitting it to a training and validation set. But if you're missing the fact that you have a shift in your data, you will try and devote yourself to creating more complex feature engineering, more complex models, and just waste a lot of time and energy trying to model something that you don't actually understand. And let's say that you've even managed to do that and you've put a model in production, then you still have to monitor it on time just to make sure that non-stationarity effect takes in and you have a model degradation, no performance degradation in your model. So keep that in mind, because you need to find it on time and avoid time and energy and money waste. So now that we know why it's so important to find them, let's see how to spot the different types of shifts. The easiest way, visualize your data. This simple snippet of Python code, you can find the source in this QR code, will actually show you that, let's say that this is the training data set and this is the test data set, and they seem very different. But according to our code, they actually 68% match in the distribution. So that means that basically, yes, you can work with this data as a single experiment. So we just need to visualize it. And no matter the domain that you're working in, whether it's image or text, every type of domain has their libraries for comparison of distributions. And you just need to Google it and find it, and just be very, very skeptical when you work and try to question everything that you know. And if we're talking about trying to find a degradation in performance due to non-stationarity, that's when the population stability index may help. Some intuition about the formula. The idea is that the index compares different distributions either over time or some group or some segments, and it tries to compare the different shifts in distribution over time. So if there was no shift, the PSI score will get a 0, and that's good. The lower the index, the less shift you have. So if we look back at the number of flights that we've seen earlier on, that's when we can see that even from January 2020, there was this peak, very steep peak that was trying to climb. And that means that there was some form of shift going on within the data. A rule of thumb says that as long as you're below 0.1, that means that your stability index is okay. But you can see that even then, this huge climb means that if you had a model in production, then you need to be aware of it and track it more closely. If you're above 0.25, well, that means that you probably need to retrain your model and try to understand what's causing this divergence in your populations and their distribution. The data will never, ever tell you the 360 of the complex problems and domains you're working with. So don't try to be a hero. Speak to a domain expert. They will either provide an answer or a solution that will make you see your reality clearer, or they even can suggest a data source that you can add to your problem modeling and create a better model. So ask them, they have the experience, they know the domain better than you do. So don't do it all by yourself. And now that we know how to spot those different shifts, we must correct them. The most obvious thing to do probably is to get more data. You have some undersampling. What's the problem? Get more data. You have a bias that you found in your data. Not a problem. Get more data. But it's not as easy as it seems, and more data is usually unavailable. And that means that you have to do with what you got. So basically, that means that you have to either resample or reweigh the samples that you do have to try and align better the different distributions that you see in your data. Even more advanced techniques like KMM can assist you when they're trying to align the different distributions on a higher plane. You can read it, Google it, and see if that helps within your situation. Finally, if you've tried to do all that and you've tried to reweigh the samples and you see that some class is still underrepresented and you have a problem, don't fight it. Just split this segmentation, split this class into a separate model, and then you can always try and combine it back during post-processing or some ensemble work that you can do with various models. So don't try to force it into a single model. It usually never works. So just to summarize, data shifts and the different types of data shifts, they are everywhere. They're most probably in every data science problem there is, and you can't ignore them. You need to find them. You need to identify what's causing them. You need to consult people. You need to speak to your domain experts. They will help you try and understand what the problem is. And then at the end, you need to correct those data shifts to get better performing models, and without wasting so much time and money and energy on this vicious cycle. So that's it from me. It's been a really great pleasure talking to you. So thank you very much and enjoy the rest of the talks.